Hi everyone, good evening and welcome to day two of Gadget Expo. Today's session, we'll first of all be having a short, a demonstration of a project by one of our fellow students, and after that, I'll be, giving you a brief about how you're supposed to submit your project and how you're supposed to, submit it through the G form. Okay, so Gautam, if you can, begin by sharing your screen, it would be great.
Hello, can you hear me?
Yeah, Gautam, you're audible.
Yeah. So shall I begin my presentation?
Sorry?
Shall I begin my presentation
Yeah, you can
are you
begin. You
gonna?
can.
Okay. So yeah, hello everyone. This is Gautam. Uh, I'm in the second year diploma of electronic systems program. So to give a background about myself, I'm a mechanical engineer. I'm working as a CAD designer at a startup in Chennai. Uh, am I audible?
Yeah, Gautam, you're audible. You
Yeah.
can carry.
Okay. So since I came home for the Christmas holidays, I don't have a live model with me. So I have prepared a PPT presentation for the project. So shall I speak? Is it visible? Okay. I'll start the presentation. So my project for this.
Gautam,
Yeah,
just
yeah. Okay.
I'll need to address one important thing. Kajal,
Okay.
you can hear me, right? I just need to.
Yeah.
Yeah, for all the new students who are, who you asked to DM you their IDs, just don't do that because we can't, handle all of that. We'll deal with them later. Okay, I'm putting you a message on WhatsApp. Just please check it out.
Okay, got it.
Yeah, thanks.
Hello, Aditya.
Yeah, Kajal, I've sent you the details, so please take care of that while we get back to this presentation.
Yeah,
So,
sure. Okay.
yeah, thanks. So, yeah, Gautam, you can carry on. Sorry about that.
Okay. Yeah. So is the entire screen visible?
Yeah, it's visible. We can see your screen.
Okay. So my project for the Gadget Expo presentation is autonomous rooftop garden watering robot. Uh, my interests lie in CAD design as well as circuit design, and this is my first venture into robot designs. So since I'll be spending a lot of money for this project, I wanted to do something utilitarian that I can use for everyday life. So here in my home, we have a rooftop garden. So the problem is it's in the second floor. It's in the terrace of the second floor. So each day, my mother used to walk up two flights of stairs and water them each every morning and evening. So I mean, she's getting old. So I wanted to create a robot that takes care of the watering for the rooftop garden. So this is the robot which I have come up with. So since I'm a mechanical designer, so the initial thing I came up for the project was mechanical design for initial mechanical design for the robot. So what I visualized for this project was it should have a three-axis robotic arm that individually targets each and every part and waters them independently, and they are powered by a stepper motor, and the steering is controlled independently by using servos. So the water will be carried using a storage tank in the middle. So this is what I've come up with for the initial idea. And so to build it, I've broken up the project into three separate components. First, for the robotic arm, I've used aluminum extruder profiles to construct the robotic arm, and I have also used the MG995 servos. Yeah, for the chassis, I've used the same profile. That's 20 cross 20 profile, which is easily available online. Yeah, for the step for the mobility, actually, initially I was planning to use mechanism wheels and gear DC motors. But the thing is, in case of a terrace, the surface is quite uneven. So for uneven surfaces, I usually observed a lot of wear and tear on the mechanism wheels and the gear DC motors. So I went with the normal wheels, and yeah. Even if I use the metal gears for the gear DC motors, I usually observe a lot of wear on that. So also for mobility, I've used stepper motors, and since I'll be dealing with a lot of weight, since the robo will carry around approximately 5 liters of water, so I needed a lot of torque. So I've gone with a warm reduction gear for the mobility. So I've used 3D printed warm gear as well as spur gear for the rear wheels. And initially, I was planning to use Arduino for controlling the robot, but later I went on with ESP32. So I'll explain the reasons the latest way. Yeah. So for controlling a robotic arm, usually inverse kinematic calculations will be used for determining the angles of the joints. But yeah, the calculations will be a little tedious. So I went with mechanical simulations to determine what should be the correct angles for the robotic arm, and input the angles from the mechanical design directly into the code. So in this way, uh, I mean, it's very easy compared to doing manual kinematic calculation for each and every contact. Yeah, I've done the same thing for the steering. Initially, I wanted to go use an Ackerman steering for the front axle, but yeah, it was a little tedious. So, since this is a very small robot, so I went ahead with independently controlled steering wheels.
Gautam, are you still on the first page? Because that is what we're seeing. I don't know if you've scrolled it up. We can still see the first page of your presentation. Have you
No,
kept it that?
no. Uh, can you hear? Can you hear the entire presentation? Wait, let me see.
Yeah, we can see the first page where it's written autonomous rooftop garden watering.
No, I have gone. I have gone to the fifth slide.
I think your
Okay.
presentation is frozen for some reason.
Wait, wait. Wait. What about now? Yeah.
Yeah, we can. Yeah, you're on the first page, right? Okay,
Yeah.
now,
This is
yeah,
the first page
we can.
actually. This. Yeah. Okay.
Yeah,
Okay.
go ahead, go
So
ahead.
should I begin the presentation from the start?
Yeah, the initial slides you can just spend a
Okay.
couple of.
Okay. Yeah. Okay. 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 As I said earlier, since I'm a mechanical designer, I started designing. I started mechanical design of the robot. So the three components which I mainly uh, uh, plan for is three-axis robotic arm, independently is a steerable front axle, and stepper motor control the rear axle. And I have broken down the robot into three components. First is the three-axis robotic arm, which I have built using three MG995 servos and aluminum extruded profiles. And for the chassis, we have used the same 20 plus 20 aluminum extruded profiles, which is easily available online. Uh, as I said earlier, initially I wanted to go for mecanum wheels and geared geared DC motors. But for uneven surfaces such as rooftop terraces, there's usually a lot of wear in the mecanum wheels as well as gears in the DC motors. So I went for normal wheels as well as stepper motor for the rear axle. And since I'll be needing a lot of uh, uh, thought, since I'll be dealing with a lot of weight, approximately around the 5 kilograms of 5 liters of water. I have used a warm reduction gear for the stepper motor. I've used a 3D printed warm gear as well as a spur gear for the rear axle. And initially, I wanted to use a Arduino for controlling the entire robot, but later I've gone with the ESP32 for other reasons, which I'll be explaining in the later slide. And uh, so usually for controlling a robotic arm, we'll be needing inverse kinematic calculations to determine the angle of the joints. And since the calculations will be a little tedious, so I modeled the entire three robotic arm using a CAD software and used kinematic simulations in the CAD software to determine the angle of the joints which will be used for the robot. So in this way, I've avoided doing the tedious inverse kinematic calculations. And I'm, for the steering, I've done the same thing. I've used inverse kinematic calculations to determine the angle at which there will be no slip on the wheels in the front axle. Initially, I wanted to go for Ackerman steering in the front axle, but it was a little tedious. So I went for independently steerable wheels using servos. Yeah, and for the rear axle, I have used NEMA 17 stepper motors, and I have used DRV 8825 drivers for running the stepper motors. Yeah, about for this project, initially I wanted to go for a single stepper motor, but the problem is due to a lot of weight, especially due to the chassis as well as the water storage tank. There was a lot of weight, and a single stepper motor couldn't push the robot, so I had to go for two stepper motors. And for the front axle, I had to use two NG995 servos for independently steering the front axle, front wheels, and three servos for the robotic arm. And I will be using two IR sensors for the line following, as well as a moisture sensor to detect the moisture in each and every part using the robotic arm. And I'll also be using a load cell for calculating the weight of the water tank, and the voltage sensor to read voltage of the battery, and a reed switch to calibrate the robotic arm, and a water pump relay to pour water to control the pouring of water. Yeah, and as you can see, these use a lot of IO pins, and and I'll also be using a Wi-Fi, and so it will also require a separate module for the Arduino. So since this will be using a lot of IO pins, I directly went for an ESP32. And yeah, to reduce the weight of the garden robot, I modified the design to a simple one. Uh, yeah, uh, this is the second version of my robo, in which I have completely eliminated all the aluminum extruder profiles. Yeah, and for this robo, I'll be using three microcontrollers. One, I'll be using the ESP32 cam, which will be attaching to the front of the robotic arm, which is a master control, and another ESP32 to control all the motions, that is the rear axle, front axle, as well as the robotic arm, and another ESP32 that's used in the docking station. Yeah, this is just a PCB. Yeah, for communication between these three microcontrollers, I have used a protocol called ESP now. This is only available for ESP32 boards. So initially, for the ESP32 cam, I'll be controlling it using a web server, and the ESP32 cam sends commands to the robot ESP32, and the ESP32 robo is in communication with the docking station ESP32. Yeah, to control the ESP32 cam using a web server, I have developed a app using the MIT app inventor. So here I have attached the ESP32 cam uh, to the front of the robotic arm, just above the moisture sensor. So if you want to capture the image of the present image of the robo, we can simply use the capture button here. And yeah, this is a sample picture that's a screenshot of the app. And we can also control the robot using a start and stop button from the app itself. Yeah, and this is setup I have prepared for the docking station. So for the docking station, I've used a separate ESP32. Since this will be autonomous robot, uh, the charging and the refilling of water is also autonomous. So I've used another ESP32 to control the filling and the charging of the robo, and this will take continuously take inputs from the robot. That is here. There will be continuously input from the robot, such as voltage from the battery and the weight of the water storage tank from the load cell. And if the voltage of the robo battery falls below a certain level, the robo will automatically go to the dock, and will automatically charge itself using this wireless charger. And if the water storage level is low, it will automatically control the solenoid valve, and it will also fill up the tank. And yeah, so for the initially I've done some field testing using some parts within my room. So is the audio playing, Aditya?
We can't hear the
Is it?
audio. The video is visible to us.
Is it? Okay, okay, okay. So
Yeah,
I've
I
done
think
some field testing.
audio
Okay.
you'll have
Hello?
to share tab audios. There's some setting, I think.
Yeah.
Maybe try starting your presentation again. Sorry, starting your screen sharing again and select that present audio. Some option is there. Make sure to select that.
Um, okay. I'll stop. No, it's not there.
Okay, then if it's not there, then that's no.
Anyway, yeah, yeah. The audio is not a thing here. Anyway,
Yeah.
yeah. For the second version robo, I've done some field testing using some parts within my room, and I've laid down some tracks for the line following. So here I've not used the ESP32 cam as well as moisture sensor. This is just to uh, determine if the robotic arm is actually turning in the right direction and it's properly following the path or not. Yeah, and here I have included the water pump as well as yeah, a temporary water storage bottle. Yeah, and finally, I have also included a moisture sensor. Here, this will check if the check the moisture content of the pot before pouring. Sometimes in rainy season, uh, the pots will already be wet. So in such cases, there'll not be. There's no need for any water pouring. So I've also included the moisture sensor here. Yeah, this is. This project is still ongoing, and yeah, these are some of the resources which I have used for this project. I think that's it for the presentation.
Amazing presentation, Gautam. Can
Yeah.
you just tell me one thing? I was really curious,
Okay.
given that,
Mm,
the
yeah.
what following the line. So is that it's full speed, or were you controlling the speed
It's
to
no,
get
no.
to?
It's full speed because since it will be carrying a lot of water. If the speed is too high, when it's starting or stopping, there will be. The water will jump up a little. It's called water hammer effect. So it will affect the stability of the robo. So I have reduced the speed of the robo a lot. That's why I've gone for motors actually.
Yeah, that makes sense. That makes sense.
Mm.
So, you now that since you mentioned that your robot has a water tank sort of thing, are there
Yeah,
any arrangements made for if you wanted to attach just a pipe to your robot and water from an external tank placed somewhere outside is supplying water
yeah,
to it?
yeah. Here, wait, actually, this is the solenoid valve which will be placed at a particular height, such that it will be placed in the docking station. So when the water level falls below a certain level, the robo will move to a particular position. Let's see. I'll show you the. Yeah, and the robo will move to the particular position, and the solenoid, and when the docking station detects that the robo has reached a particular position, the solenoid valve will automatically get triggered.
Okay.
So, did that answer your question?
Yeah, yeah, definitely, definitely.
Yeah, okay.
I mean, it obviously makes sense, right? If a person
Mm.
doesn't want to, have a water tank so close to his expensive robot, then he'll
Yeah,
definitely.
yeah. I think I have to consider waterproofing the entire circuit because, yeah,
Right. Because even if there is a minute leak somewhere, you risk your entire
mm,
robot
yeah,
being damaged
yeah,
by your
mm,
water.
yeah,
And another thing, I saw that you were using the soil moisture sensor. So don't you
yeah.
think it would be better if you use that sensor to be permanently placed in the pots instead of
Yeah. So for my initial project, I never even intended to go for a robot. So YouTube videos, you'll be seeing a lot of autonomous watering systems where they'll be permanently placing a moisture sensor, right? So uh, initially I was planning to place. In my rooftop garden, we have 20 or so pots. So initially I was planning to purchase 20 or so moisture sensor, but it was kind of the pots will be exposed to atmosphere. In case of rain, the moisture sensors will get affected. And also, I have noticed that the the tracks in the moisture sensor they tend to corrode easily. So if it's placed permanently in any pots, it will get damaged within a week. So instead of spending a lot of amount on moisture sensors, you can have a single moisture sensor attached to a robotic arm, and it will use the same moisture sensor independently for all the pots. So in case I'm planning to increase 20 pots to 40 pots or 60 pots, so I can use the same robo instead of spending additional money for buying extra moisture sensors.
right, right. That makes sense actually.
Hmm.
Okay, there is someone in the chat asking, can we comment suggestions? You definitely can
Yeah, sure, sure, sure. Yeah,
put up your suggestion.
I'm happy to have suggestions, man.
Yeah, definitely. Please use the chat to
Hmm.
do that.
Yeah.
And in case all of you have any questions you want to ask Gautam about his project, then you can certainly do that as well.
Hmm.
And if you need some time to type it out in the chat, please take all the time you want. We have a couple of more minutes left. So, okay, Gautam, just one last
Hmm.
thing. You
Hmm,
will,
sure.
I hope you will be bringing this project of yours to the offline Gadget Expo.
I I sure hope so. But yeah, let's see because these things cost a lot. So yeah, I'll try to make it because I stay near Gindi. I
Mhm.
mean I stay near the IIT Madras campus. So I'll try to bring it.
Yeah, definitely. If you bring it, then it will
Yeah.
be really
Mm,
great
yeah.
thing to see for
Mm,
all students.
yeah.
Perhaps we can set out a black tape on the floor and you can give a live
Mm,
demo
sure.
line follower.
Sure. Mm,
Right, right. Uh, so yeah, that is all from my side, I guess. So from the audience, once again, if you guys have any questions, then you can please make full use of the chat box provided to you. You can post your questions there, and Gautam will get back to you and answer them. Okay, I think we do have one question, Gautam.
yeah.
Yeah, I
Yeah.
think, yeah, it's visible to you, right? I hope it's visible.
I think someone is saying to use capacitive moisture sensors, right? Yeah, actually, that's a good idea. Okay. Capacitive moisture sensors, extra safety, maybe a coating of nail polish or lacquer wood. Yeah, okay. I think that's a good idea. No, I don't have a YouTube channel.
Okay, then the person who suggested Gautam to use capacitive sensors. If you're visiting us in the campus, then please make sure to visit Gadget Expo during the labs, so that you will be able to you will get a chance to speak to Gautam in person, and at the same time, you can also discuss more topics related to that. Okay,
Yeah,
so
and
yeah,
yeah, and I have to give my thanks to actually you because I was never even interested in robots. Basically, my hobby is in circuit designs and mechanical CAD designs. So when I came for the embedded lab, actually you presented the robo, I think, right? The mechanical wheel robo.
correct. Yeah,
Yeah.
that was.
So basically you are my inspiration for this project.
Yeah, that is so nice to
Yeah.
hear. Actually, I had
Mm.
used the Mecanum wheel robot. I had bought it from both lab slots, and
Yeah.
for the first lab slot, Professor Nitin he himself held up the robot so that everybody could
Yeah.
see it. Yeah, I think
Yeah.
it was the
I
first
was,
lab, but I remember seeing you there.
yeah. I was in the lab.
Right, right. So yeah, I mean, it's great to hear that, man. So nice to hear. And
So,
yeah,
so
definitely. If you have any more project related to robots, then please let me know. I'll try to provide my inputs through
yeah,
the.
sure, man. Yeah, sure.
And
Yes,
yeah, that
anybody
is.
else have a question?
Thank you so much for your time, and thank you so much for your presentation. I think you can stop presenting now.
Okay.
Okay, guys, so that brings us to one important note or an address which I would like to make regarding Gadget Expo. So, what we have noticed is there are many students who have registered for Gadget Expo. They would like to showcase their projects and the gadgets which they have made on their own. So, for that, what we'll be doing is we will be releasing a form where you will be asked to submit your you'll be asked to record a video first of all of you explaining your project in detail. You will have to record a video of you demoing it as well, a live demo basically, and you will also have to submit us a PDF report of your project, explaining how you have built your project and explaining all the details basically. So this Google form, it will be released only on the Spark Google Space, and it will be released only in the Spark WhatsApp community. Okay, so if you are interested in, if you're interested in showcasing your project to us, just like Gautam did it a couple of minutes ago, then please consider filling out the Google form which we have already released, which is the registration Google form for Gadget Expo. Please fill that out, and after some time, we will be releasing a form where you will be uploading all this, which I just told you. Okay, what did I tell you? You're going to have to upload a video of you explaining what your project is, how you built your project, along with a live demo. And the second thing is a PDF report. Okay, all the details will be shared in a Google form, and in that same Google form, we'll have to upload that. Okay, so you'll be getting some time, 2 or 3 days. So you have a significant amount of time if you want to edit your video or shoot your video in a proper manner. Okay, so please make sure, even for the people who will be watching the recorded version of this Google Meet on YouTube, this meet is being recorded externally. So for those of you who are joining us through YouTube, please make sure to note the points which I just mentioned, so that you get a fair chance when you participate for Gadget Expo. So that was the main thing. Also, here, can you just raise your hands if you are one of those people who are interested to showcase your project? I would just like to see how many of you are here in this meet, actually, because we have received, a quite large number of registrations from ES, at the same time data science, and we want to make sure that all of you are given a fair and an equal opportunity to showcase your projects to us. Okay, I don't see any raised hands. So, okay, one. Ravikant. Okay, just one, because there were many people who raised it. Okay, so most of you will. I agree that I need to accept this fact that most of you have joined to see what others have done, which is again an amazing thing. So, uh, okay, so Ravikant, just give me a minute. I'll ask you to unmute because I want to know what you have made. Uh, just a second. Okay, Ravikant, can you unmute yourself? I think you have privileges now.
Am I audible?
Yeah, Ravikant, we can hear you. Go ahead.
First of all, I want to say thanks to all the coordinators as well as volunteers for organizing these events. And now I am showing our demonstration. Our demonstration is basically a control unit of a car. Okay, and I want to show some features of that car. Okay, firstly, I will explain the features of the car, and I will demonstrate it lively. Okay.
Definitely, you can do that. Go ahead.
The first feature of this car is seat belt indicator, and the second features of this car is door indicator. And when the driver in the car is become unconscious suddenly, and due to this reason, car accident, the chances of car accident will be more. Okay, so that I have made a steering. That's when the hand is dropped from the steering, the car will stops automatically to prevent the car accident. Okay, now I am going to show. Are you able to see my?
Yes, Ravikant, it is visible.
Yeah. Firstly, this is a key of that car. Okay, and when I insert them into this car, and open it, green light will open as well as blue is open, and blue light indicating that you have not fastened any seat belt. So the car allowed me to fasten the seat belt. Okay, and when there is a three doors D1, here you can see that D1, D2, and backside D3 are the three doors of this car. And when I open the doors of any when I open the any doors of the car, the red light will glow on, and it indicates alert to close the door safely. When I open one door, let me show you. This red light will open, okay? And it indicates that firstly you have to close the doors to drive the safely. And when I close the door, the red light will automatically uh, glows down. And here you can see the blue light is open. And when I when I fastened the seat belt, the blue light will glows off. Let me show you. I am fastening our seat belt. Suppose this is a seat belt I am fastening now, and this is also another seat belt which I am fast. You can see that blue light is off. Okay, that means you are fastened your two seat belts. Now you can go with safely with green lights. And here you can see that this is the steering of this car, and when we touch the steering of this car, the car will open, the car will move. uh, Let me show you. You can see car is moving, and when I left this steering, the car will. Let me show you. When I open the hand, when I drop the hand from the car steering, it will stop. Okay. And this is my project, and I have used many ICs. I have used NAND gate ICs. Here you can see that, and I have registered. And indoor, I have used a door sensor. Here you can see the door sensor which I have used, and here also a door sensor which is magnetic sensor. Okay, and here a wheel and a motor, a DC motor as well as LED lights are used in this project. Now this is my final project.
Nice presentation, Vikant. Really enjoyed watching you explain how your project works. Okay, so just tell me a few things. What kind of sensors have you used? I saw that magnetic sensor. So, other than that, have you used any other sensors which you would like to share?
No, no, I have used only a magnetic sensor which I used in a door as well as a steering. Okay.
Okay. And can you just explain us how you made that key mechanism? Only after inserting the key that car turns on?
Yeah, I have used a key switch. When the key switch is on, green light will open and the circuits will on,
Okay. Okay.
and it's ready to work.
So it's a key switch, right, which you've used.
Yeah, I have an idea taken from Professor Janki Raman, which is taught logic gates. From that, I have taken an idea to build this.
Nice presentation, man. So, okay, so for that steering wheel, when you told me that when the person is removing his hand from the steering wheel, the car will stop automatically. So, right here, you have used a magnetic sensor, right? So, do you feel that other than a magnetic sensor, any other sensor can be used, which is
Yes, because in our area there is no any available for that sensor. I have to export from the externally, and of course it will be many sensors to do this, and one of them is a magnetic sensor which I used in this car.
Yeah, yeah. I mean, I can totally relate, man. You have used all the components which was best available to you. But what I was asking was, which sensor do you feel is best suited for this? Probably like a capacitor,
This will the maybe a motion sensor will be great for that the car steering.
motion sensor. So
Yeah.
are you aware that in latest cars and all they use driver alertness sensors and also I think is that where you have gotten inspired from?
Yeah, I have inspired. I am watching a shorts video. I have watched that Japan's technology is more advanced, and it used such type of technology.
Right, right. Which car did you see using this?
Uh, I have no remember of any model of the car,
Okay, okay,
but
okay. It doesn't matter. It doesn't matter. All that matters is the technology that's being used, and all of us are interested in technology. So
yeah.
amazing presentation, Ravikant. We really liked your idea. Is there anything you would like to add, or else we can end this presentation?
I would like to add one more budgets that when the person becomes unconscious, it will warn the uh, surroundings that something is wrong with the cars. And I will add extra features to it, which emergency alarm system, which
Okay.
automatically sends the internal images of the car to that owner
Mm-hmm.
and particular companies to see the what happens inside your car.
Right, right. Anyways, excellent presentation, man. Your idea is really nice of making something for the safety of people who drive on the roads. Given that Indian roads, as you know, the situation how it is, so it is really good that you're doing something to improve this current scenario, current situation. And yeah, thank you so much for showcasing your project to us, Ravikant.
Thanks to all for giving me opportunity to present something.
Thank you, man. The pleasure is all ours. Okay, guys. Is there anyone else who would like to present? You can just raise your hand and let me know. We'll wait for a couple of minutes. And again, until somebody raises their hands, I will just like to reiterate for the people who may have just joined. If you would like to participate in Gadget Expo, just like you saw Ravikant and Gautam present their own projects, so please make sure that you have filled the registration form. If you're a student from BS in Electronic Systems, then you have to fill that registration form. But if you're a student from Data Science, then you have to fill a separate registration form which we have sent with a list of all events. Okay, and I would also like to make one other point clear. Uh, if you're a DS student, then you have already received the registration form. You will notice that there is a full list of all events. So you need to select one event individually, and you need to submit the form again and again to ensure that you have registered for all events which you are interested in. Okay, so if you are interested to register for 5 different events, then please make sure you submit the form every single time for each of those 5 events. Okay, so I hope I made myself clear. And now coming back to Gadget Expo, since we are in the Google Meet for Gadget Expo, the Gadget Expo event. The process in which we will be evaluating and shortlisting your projects is we will be sending out a separate Google form only for the Gadget Expo event, where we will be asking two things from you. Okay, the details of these two things will be provided in the G form as well, so that you have better information when you are submitting. So the first thing will be for you to record a video of your project, you explaining your project, how you have done it. At the same time, we'll be adding a video demonstration of you operating or controlling your project if it's a robot. And the second thing is a detailed PDF report of your project. Okay, all the details of how you're supposed to do this will be in that G form, and we'll be sharing that later as well. So these were the two things which I wanted to explain again and again. And okay, so I was looking for people who wanted to present. So I think I'll just wait for 2 minutes to see if there is anybody else who would like to present, just like Ravikant raised his hand, and we'll carry on with that. Okay, so since none of you raise your hands, I agree that we have a very short time remaining. So in that time, I would like to, sort of. Okay, I think we have a person who has raised his hand after I unmuted. Uh, since you are an unverified account, I would recommend you first type in the chat box because I need to take precautions before giving you privilege. So please type in the chat box what you would like to present, and if you can, I'd recommend you come back with your student ID, and yeah, I'll give you some time to state your intentions. Okay, anyways, until he does that, here I would like to show a couple of embedded systems or electronic devices which I have lying around. So the first one is this. This is a Raspberry Pi 5. It looks a bit bulky because it has this metal block on top as well as the bottom. This is a heat sink and a couple of fans so that it doesn't run hot. Okay, I'll just take it a bit close so that you guys can see. It is ridge. It has many ridges so that there is sufficient airflow. And this is yeah. So there are two USB Type 3 ports so that you have connectivity for your mouse if you want to add or any external devices, and it also has an Ethernet port. Okay, so this actually is the Raspberry Pi 4. I mistook it as Raspberry Pi 5 because I also have that here. I'll just come back to that in a few minutes. Okay, so okay, what I was saying is this is a computer in itself. Okay, so this has the capacity to run an operating system, and it already has its own Raspberry Pi OS currently configured into it. Okay, so what I use this for is actually for running remote stuff like actuating, controlling sensors for my garden, an online garden as I like to call it. So there are multiple sensors, just like the one which Gautam explained, soil moisture detection sensor. So as soon as it detects that the moisture has gone below a certain threshold, then it triggers the water pump, and it triggers the water pump for a certain duration depending on what the moisture level is, because the moisture sensor collects data every 5 minutes on summer days and every 10 or 15 minutes on winter days, because obviously during the summer things dry out sooner than on winter days. Okay, anyways, it is an embedded system. Basically it is a computer in itself which can be used for literally everything. It's a tiny handheld, not handheld actually. While computing, it can't be, you can't hold it in your hand. But the size is such that it is extremely small. This is the Raspberry Pi 5, and it is actually the later version of the one which I showed earlier with the heatsink. It can sort of do the exact same tasks, but it does it a lot faster because it is obviously the newer generation of the same board. And if you notice on this side, you will see that it has sort of the similar ports given along with the Ethernet port for internet connectivity. Obviously, you'll have to control your sensors through a wireless medium, and yeah, that's the thing. So if you guys are interested in knowing what my online garden is, it is actually just like in Gautam's presentation, he was using a robot for watering the plants and all. In my case, I haven't used a robot because this was something which I had done long back. We actually have tubes running through our garden, and we have small holes on that tube. Okay, the holes have nothing to do with the sensors or the programming. The holes are just for the water to seep out into the pots. Okay, so just as I explained, it is deadly simple. When the moisture level goes below a certain level, the pump is triggered and it waters the plants. Basically, that's how simple it is. And the computer which does this is the one which I showed you. It's this one actually, the Raspberry Pi 4, and this sits inside the house. It doesn't need to be outside because everything is wireless, but the sensors are connected to this. Okay, so that is how it is. Okay, enough talking about that. I'll also just quickly show these two. These are once again smaller computers, smaller than the ones which I just showed you guys. And this basically works on the RISC-V architecture, which we had a long discussion on with Professor Jankiraman earlier this month. Sorry, a long back actually, and we also had a small discussion in today's session with Anirudh, the electrical engineering student from IIT Madras. All right. Anyways, I think Gautam, you have something you'd like to add. That's why you're raising your hand. So let me just give you access. Yeah, Gautam. I think you.
Yeah, as I said before, I have another project. I told you, right?
Yeah, yeah,
Actually,
you're on.
yeah. Actually, that was my first idea for this Gadget Expo, but I didn't
Mhm.
want to embarrass myself.
No, it's all
That
right.
was,
If it's a
yeah,
project
it's
which you've
kind of,
done with and if it
yeah,
is something,
it's kind of,
yeah, yeah, correct, correct.
since it's kind of a simple circuit. I mean, I had this idea after the digital design. Yeah, digital design, right? um, Basic digital systems. Yeah. So I
PDS,
had
BDS.
this, yeah, BDS. Yeah. So I had this idea ever since that subject, and since Gadget Expo was mentioned, I thought of exploring that idea. So you know about the SR latches, right?
Yeah, yeah. I just see
Uh,
you sent it to me, right? You're talking about that one.
the SR latches, the set reset latches. I
Yep.
mean, it holds a particular state, either on or off. So I had this idea. So for in a simple SR latch, there will be usually two states. But in real life, there will be, I mean, we will require a lot of states. For example, let's say traffic lights will require three states, either red, green, or yellow. And even in industrial signal towers, there will be three states, or four states, or five states, depending upon the machines. So I thought, I mean, usually in industrial assembly lines, they'll usually use PLCs or microcontrollers to control the lights. So I thought of using a modified SR latches to simplify the whole thing.
Mhm.
So I have a presentation. So I'll put it up. Let me share the screen.
Yeah, 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 sure, sure. Okay, until then, I'll just unmute our one participant here who has raised his hand. I'll just, I'd like to
Yeah,
know
this
what.
will take just 2 or 3 minutes. Also.
Yeah, yeah, sure, sure. Take your time. Dipanjan, I think you can unmute yourself now. Can you let us know what you would like to share?
Yes, yes. So my idea is also related to the SL latch, and it's a simple circuit.
Okay, okay.
Uh,
We'll give you some time. So after Gautam is done with his short presentation, you can go ahead. Okay?
okay, okay, okay.
Okay, perfect.
Yeah, in a SR latch, the collector of one transistor will be connected to the base of the another transistor. So when a transistor switches on, it will, I mean, when a transistor switches off, the collector voltage will turn on the other transistor. So that's a basic concept of an SR latch. So here there will be two transistors. So two states will be actually maintained, either on or off. For a single transistor, there will be a single state, right? So what I was aiming for was why not use collector voltage to control the base of two transistors, or even three transistors, or multiple transistors. So when I initially searched for the idea online, there was no such thing. So here, yeah, here I've used three transistors, and I've connected the collector of one transistor to the base of another transistors, and I've done the same thing for all three transistors. So all three transistors are coupled together instead of two transistors in case of a SR latch. And I've also connected the collector of all the three transistors to three MOSFETs, which in turn will be used to control any high voltage supply, something like traffic lights or industrial signal towers or something like that. So I had this idea after the course. So for this Gadget Expo, I wanted to explore what it's like as a product. So here, industrial signal tower. So usually, in case of an emergency, the worker will press a red button, and the red light will glow. And in case everything works perfectly, then the worker will press the green button, and the supervisor can view the status of each and every work table from a long distance. So here I've tested the circuit using breadboards. Yeah, and I also wanted to go for a PCB. Uh, As you can see, I have developed a PCB for three states, but this can also be adopted for multiple states. But I don't know the limit of it. But perhaps we can adapt this for five states, six states, or something like that. So, compared to using microcontrollers or PLCs in case of workstations, if we use this type of circuit, then it will be a lot cheaper because for this PCB, uh, I just spent around 1,000 bucks, but mostly cost of the PCB is around 100, and the circuit only costs around 10 rupees or so. So this will be a lot cheaper alternative compared to microcontrollers or PLCs. So yeah, have you heard of the circuit anywhere?
I don't recall as of now, but it looks sort of similar or familiar.
Hmm.
But is it the same one which is used in those pumps,
Which pumps?
water pumps to
No, 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 no. They don't
they.
use electronics. Actually, they use electrical relays, not electronics.
Mhm.
So yeah, that's why. I mean, I didn't know if this was an original idea or something like that. So I don't want to embarrass myself.
No, it's okay as long as you've done something on your
Yeah,
own. You are free to
yeah,
demonstrate your project here.
yeah. So Dipanjan also had a similar idea related to
Okay, Gautam, thanks a lot for the second part of your presentation. I think it's time we talk to Dipanjan also. So just give me a sec.
yeah, yeah, sure.
Dipanjan, I think you can unmute yourself now, right?
Okay, okay. My idea is it is about when I searched for something like a random number generator in something like for giving a number, like there are some games that uses random number. So when I try to search it that how computer does the random number generation, I get that there are some certain algorithm which produces a pseudo random number instead of a real number random number. So during when I was learning about SR latches, I come to know that when SR latches is start in the beginning, it automatically one of the outputs are come high, which is not dependent on the previous or any other conditions. So I have thought of that thing. So can I show my presentation?
Okay, but we are actually running out of time as well for today's event.
Only
So,
2 minutes, right?
okay, sure, sure. I'd suggest you turn on your video also so that
Yes, yes.
everybody
Okay,
can
okay.
see.
Thank you.
Yeah.
So here is my simple SR latch. So when I turn on it, then one of the output goes high. Either sometime it is this output and or sometime it is that output. So I have tested it on breadboard also, but the problem is it is not consistent enough. I think due to the length of the wires, but I am trying it to make it more perfect in the breadboard. So I don't know it's how much effective, or does there any another kind of solution, but that's what my idea is basically.
Nice, nice, amazing. So if you want to, develop this further within the next few days, then please do so and come back for the next session. If you want to show us something more, we'll definitely be able to accommodate you. Okay.
Okay, okay, okay.
Okay, Dipanjan. Thank you so much for your time and presenting this idea to us.
Thank you.
Okay, guys. So thank you so much, everybody, for joining this Gadget Expo session number two. Today's day two of Gadget Expo. Oops, I went the wrong person. One sec, one sec. Okay, so this is the end of day two for Gadget Expo. So for the next sessions, we have sessions all the way until the 28th, I think. Spark Online runs until 29th. The Gadget Expo's last session is on the 28th of December. So you have time until then. Please don't keep yours for the last day, because if everybody keeps it for the last day, we'll have a lot of trouble accommodating everyone in the end. On the session on the same day. So please submit your ideas as soon as possible, and please let us know whenever you're ready to present your ideas. Okay, so we'll be giving you access and privileges in the Gmeet, just like we did for today's participants, and you can just carry on and begin by presenting your ideas. Okay, you can turn on your video and start explaining your project. Okay, it's as simple as that. So once again, thank you so much, everybody, for joining. We'll be ending the session soon, within the next 2 minutes, and until then, we'll see you next time. Okay, please keep in mind all the things I told you so that you're better prepared. Thank you so much. Have a good night. Bye bye.